Day 2 of section 4.3, factoring quadratics, special forms. Now let's say you're taking a quiz or a test and you see this earmuff problem. So blank times blank equals 1764, blank plus blank equals negative 84. Now, I don't know what this is. I don't expect you to know what this is. I don't expect you to keep trying things to find it out. Instead, we're going to use a different method. This is actually something called a perfect square trinomial. Perfect square trinomial is something that simplifies to a single parenthesis squared. All right, now to figure out if something's a perfect square trinomial, we want to look, at least to start, at the first term and the last term. So when you look at this first term, you should notice that this is actually a perfect square, okay, meaning that we can square root the 36 and the x squared. Okay, same thing with this last term. Okay, we can square root a 49. Okay, now one thing to note is that last term has to be a positive. If it's a negative, we can't square root it. We're not allowed to square root a negative number. All right, so we can square root that 36x squared, it becomes 6x. Square root the 49, it becomes a 7. All right, now there's one more thing we need to check to make sure it's a perfect square trinomial, okay, is we want to multiply those two numbers, 6x and 7, and we want to double it. And we want to see, does it match this middle number? Okay, and we ignore the sign. We don't care if it's positive or negative. We just want to see if it's the same actual value. So 2 times 6x times 7, 84x, that's what we have in the middle. That is a perfect square trinomial. All right, so our answer is 6x minus 7, inside parentheses squared. The minus sign comes from that minus right there. Okay, so if that had been a plus, that would have been a 6x plus 7 instead of a minus. All right, number 2, this one isn't as complicated. You probably could do this one as an earmuff problem if you actually wanted to, but let's go ahead and do it as a perfect square trinomial just for the practice. So square root, we get 2y, we get a 5. Right? If we multiply 2y and 5, we get 10y. Okay? If we double it, does it equal the middle? Okay, it does. They're both 20y. Right? So the only other thing that we need is this sign right here. 2y plus 5 inside parentheses squared. Next special form is called difference of squares. We want to use difference of squares when we see two things in our problem. Again, both perfect squares separated by a minus sign. Now, in every problem, we always want to check to see, is there a GCF that we can take out? In number 3, we have two even numbers. They're both divisible by 2, so we can factor out a 2. Okay, take a 2, move it to the outside of the parentheses. Now we have a 9x squared minus 25. Okay, inside the parentheses here is really something that we would recognize as a difference of squares problem because that's a perfect square. We know that we can square root a 9. Okay, same thing with the 25. All right, so once we see those two numbers, hopefully we would realize we can square root those. Okay, and we would give that a try. Okay, so square root 9x squared, we get 3x. Square root 25, we get 5. Okay, and when we do difference of squares, we write two parentheses. One is a plus, one is a minus. Okay, the two things we get are going in both parentheses, okay, in the same order. So we take this 3x plus 5, and we're going to write it in the first and second spot in both of these parentheses. So one's a 3x plus 5, one's a 3x minus 5. Okay, and also don't forget that we have this 2 that was out front. Okay, make sure that is in your answer. So 2, 3x plus 5, 3x minus 5. Number 4, okay, no GCFs here. We're just going to square root these. 6y, 7. Okay, we have to have a minus in between these. If it's a plus, we can't do it. Okay, so that's going to turn into 6y plus 7, 6y minus 7. Now this problem has an equal sign, an equal to 0, which means just like that problem in the last set of notes, once we have this factored form, we want to split it into two parts. Okay, set each parenthesis on its own equal to 0, solve each of them out, and get two solutions. Okay, so anytime an equation has an equal sign, we're looking for solutions. If it doesn't have an equal sign, like number 3, we're looking for an actual factored answer. The last special form that we use is called factor by grouping, and we look to use this when we have 4 different terms in our problem. So in number 5, xy squared plus 2y minus 4xy minus 8. So we see we have 4 terms here separated by pluses and minuses. And in factor by grouping, we're going to split this problem right down the middle. Okay, now once it's split, we look on each half of it and take a GCF out of each half. So for example, on the left side, the GCF of this side is a y. Okay, on the right side, the GCF is a -4. Okay, so now we're going to go ahead and factor the GCFs out of their respective sides. Okay, so we take the GCF out of that left side, factor that GCF out, divide by y, and we're left with that set of parentheses. Here, divide by -4, divide by -4. Okay, we're left with this one. All right, now, if we do this correctly, and it is a factor by grouping problem, these parentheses will always match one another. If they don't match, either we've done something wrong or it's not a factor by grouping problem. Okay? And this is actually going to give us one of the factors in our answer. So the first half of our answer is xy plus 2. All right? The other half of our answer are the 2 factors that we took out, y minus 4. So we go ahead, we write our answer, y minus 4. Okay, those were these 2 factors in green there, and xy plus 2. Okay, same thing for number 6. GCF of the left side is a y. GCF of the right side is a 7. Okay, take those factors out of each side. Okay, and when we do that, we're left with each of these parentheses on the bottom here. Okay, we can see these parentheses match each other, and we have these left over. Okay, there's no sign in front of that 7. We just took out a positive 7, so it was really a plus 7. So our 2 parentheses, y plus 5, y plus 7.